Hello again, math students. As we continue our review this week, we're going to go back to solving equations for a day. We want to make sure that everyone remembers all the steps and how we show our work when we're solving equations. So we want to think about when we're solving equations, how to get rid of stuff that's with our variable. So if we had addition in an equation and we wanted to get rid of it, we would use the inverse or the opposite of addition, which would be subtraction. If we wanted to get rid of multiplication, we would use the inverse, which is division. If we wanted to get rid of subtraction, we would use the inverse, which is addition. And for the last one, if we wanted to get rid of division, we would use multiplication. Remember, we're always just going to use the inverse or the opposite operation. So when we are solving one-step equations, like these four problems right here, we've got one of each kind: addition, subtraction, multiplication, and division, just to remind you of how we show our work. And when we do the work for this assignment, you need to show the work, just like we did when we started all of this. If you remember, usually we started with a vertical line through the equal sign. And I have x plus 4. I don't want that plus 4. I want that to go away. I want the x by itself. So to get rid of addition, we would use the inverse, which is subtraction. We're going to subtract 4. Now, over here, it's easy to see that part's going to go away. I'll have my x. I have my equal sign. This part on the right gets a little bit more messy for some people. I would suggest that you do a keep, change, because this is now negative 10 plus negative 4, which is a negative 14. And if we would check that, if I would substitute that number right here for this x, I would have negative 14 plus 4. Oh yeah, that is negative 10. Number 2 below it starts with subtraction. So to get rid of subtraction, we would use addition. Some people want to change this automatically to a keep, change, which you certainly can do. I personally would rather leave that as just p minus 8, because then the inverse of subtraction, the opposite, would be addition. So I'm going to get that p equals 21. And if I would substitute and put that 21 right there for that, I would have 21 minus 8. Yep, that's 13. Number 3, I need to get the z by itself. I need to get rid of multiplying by negative 4. So I would divide by negative 4. Remember, we show division with that fraction bar. We do not use this kind of division. We do not use this kind of division in equations. Those are arithmetic ways to show division. But in equation, we use algebra. We use algebraic methods. And this is how we show our division, is with these fraction bars. So negative 4z divided by negative 4 just leaves me with z. That's what I wanted. And 28 divided by negative 4, they're different signs. So that's going to give me a negative 7. For number 4, I would want to get rid of dividing by negative 3. To get rid of division, we'll use multiplication. Now, multiplication is the only one that doesn't go under. For adding, for subtracting, and for dividing, every one of those problems we've done so far, I did something underneath my equation. This problem, that doesn't happen. I would multiply on the sides here. So I would be multiplying by negative 3, because that's how I get rid of dividing by negative 3. And again, it goes on the sides, not underneath, because I want to see this almost. The reason we do it like this is so that I can see it like a fraction, like that's going to cancel out that. Okay? Or dividing by negative 3, multiplying by negative 3, cancel. So I have my w. Negative 12 times negative 3 is positive 36. When we have two-step equations, you have to keep in mind what you want to get rid of first. In number 1, when I am trying to decide what to do first, I've got the 4 that's attached to the x, and then I'm subtracting 8 equals negative 12. when I solve these kind of problems. Whatever is attached to the variable, in this case, the 4, that is the last thing that's going to go away. We're like undoing order of operations. So to get rid of subtracting 8, I would add 8. So I have 4x left. Notice again, I am rewriting the 4x. Underneath that horizontal line, I want to see what I have left in my equation. Negative 12 plus 8 is negative 4. Then I would divide by the 4. Remember fraction bars. X equals negative 1. For number 2, I would notice that the m is connected to the negative 2. It's not a multiplication, but it is a division. And those two things, the m and the negative 2, those are stuck together right now. I have to get rid of the 9 first. So to get rid of adding 9, I would subtract 9. Both sides. So I have m over negative 2 equals 3. Now, I want to get rid of dividing by negative 2. To get rid of dividing, I'm going to multiply. Remember, this was on the outside, so multiply by negative 2, multiply by negative 2. Gone. So here's my m. 3 times a negative 2 is a negative 6. Now, I didn't check the first equation, but we could certainly check any of these. Again, it's just a substitution. If I would put that negative 6 right here for the m, I would have negative 6 divided by negative 2, which is positive 3, and 3 plus 9, yes, that is equal to 12. For these last two problems, multi-step equations, we have more to do here. Both of these have some distribution, that's the parentheses. I know for order of operations, we do the stuff inside parentheses, but in both of these problems, if you look at what's inside the parentheses, I can't do anything. I can't do r minus 8 because I don't know what the r is. I can't do g plus 5. I don't know what the g is. So I can't do any of that. So I'm going to work on getting rid of the parentheses. I would start with a keep change right there, and then I would distribute the negative 2. So negative 2 times r is just negative 2r. And negative 2 times a negative 8 is positive 16. Now, to solve this, again, the negative 2 is attached to the r, so we're going to leave that alone. I need to get rid of the 16. So I would subtract 16 on both sides. So negative 2r equals 44 minus 16 is 28. And then I would divide by negative 2. And r is going to equal negative 14. Again, if I check this with a substitution, when I put the negative 14 in place of the r, when I put it right here, negative 14 plus a negative 8, that would be negative 22, times the negative 2 in front would be a positive 44. And for number 2, doing our distribution, I'm going to have 4g plus 20 plus 2g equals negative 16. This time we have like terms. So I would want to combine those g's together to get 6g. Notice I just combined. I didn't like subtract 2g, subtract 2g. They're on the same side. We just combine those like terms. Now I need to get rid of the 20, so we'll subtract 20. 6g equals negative 36. And when I divide by 6, I'm going to get that g is negative 6. If I substitute that in, when I put that negative 6 right here, negative 6 plus 5 is negative 1. So 4 times negative 1 is going to be a negative 4. 2 times a negative 6 is a negative 12. And negative 4 plus a negative 12, yep, that's equal to negative 16. So that's the end of the lesson today. Make sure that you show all of your work when you're solving equations, and let me know if you need any help.